The third pilot is called the use of alternative materials for plastic mulching film. And first of all, let me apologize for this thick presentation. My purpose, or our purpose, was that you had all the information available, but I will try to make the presentation the most interesting possible. I won't read everything, don't worry. Regarding mulching, it's just a minute. Mulching is an agricultural technique which consists in covering the soil with a very thin material, and it helps preventing weeds and preserving soil humidity. And in summary, it increases crops productivity. So it's a quite used technique, and we could consider it essential for horticultural greenhouse sector. The problem is that thin plastics, such as low-density polyethylene, are considered or are classified as difficult to manage waste because of the great presence of vegetable waste and sand, and because they are highly degraded after use. Therefore, the companies, the waste management plants that should accept this kind of waste sometimes do not accept them for being considered low profit. So, although this is not the general situation, it's not a common practice, and I want you to know and to have this point quite clear. It's not a common practice, but the consequences are paid by the whole sector. And some farmers, upset of the situation, sometimes abandon plastic close to water courses. But this is not something that happens for all the farmers and every day. But it's something that we have to avoid. So a possible solution could be the use of compostable or in-soil biodegradable plastics, because these are film plastics that can lately added as soil conditioner. So this solution will be somewhere between the recycling and recovery, according to the hierarchy established by the Waste Framework Directive. Just a minute. Okay, the specific goals of this pilot were to confirm technical outputs of the new materials, of the alternative materials, and to confirm the suitability of these materials from mechanical properties point of view and also from the biodegradability point of view. The company that was chosen for this pilot is Casur, and it was the reason why we chose it. It's because it was quite representative from the sector, and also because they own an experimental farm that could be used for testing alternative materials. The first alternative, of course, was the conventional one, the use of low-density polyethylene. And this material is estimated to take more than 300 years to be degraded. That's why it's really important that we substitute conventional materials. Waste management companies sometimes do not accept these films because they are very thin and they are highly damaged. And another important problem of the sector is that they don't have an EPR system, which means an extended producer responsibility system for this kind of materials. What's the first alternative? A compostable mulching film, which is a material really consolidated in the market. It's produced by BASF, the chemical company. It's called EcoBio, and it's partially bio-based. It's 7% PLA, polylactic acid, and this plastic has all the certificates for composting and for in-soil biodegradability, and it would have to be collected after the crop campaign and taken to a composting plant. And the second material, an in-soil biodegradable mulching film. In this case, we are talking about a non-commercial choice. It's called biomulch, and it was tested in an H2020 project. Its composition is quite similar to the first one, to the previous one, but we don't have any certificate guaranteeing the biodegradability. And this one, unlike the compostable one, requires an inoculate of microorganisms that are added to the soil. It mixes with the plastic, and then they are incorporated to the soil. We divided our experimental farm in different rows, and we marked each row with a different color. We drew different squares, what surface control surface of 1 square meter, white color for ecobio for compostable plastic, blue color for biomulch, in soil biodegradable plastic, and orange for low density polyethylene. And all the alternatives were tested according to the visual assessment that was performed with high resolution photography on a monthly basis, mechanical parameters tested also on a monthly basis, and at the end of the period, we would have performed biodegradability tests. But later I will tell you about this because we finally couldn't do this type of test. I won't stop too much here. I want just you to know that this pilot started July last year. And here you have all the stages that this pilot has comprised. I want you to know that this pilot was particularly affected by COVID-19 delays. We couldn't take samples, random samples that we took on a monthly basis from March to May because of the lockdown that we suffered in Spain because of the emergency state. And it finally it ended last June. But in the middle, in the meantime, we found some problems because one of the companies that was in charge of performing mechanical analysis closed due to the pandemic, and we had to find another company. The composting plant that was supposed to be working before the pilot ended finally couldn't be ready, so we have had a lot of problems. But at the end, we can say that according to the visual assessment and also to the outputs that we have found these materials present all over the crops period, we can say that although low density polyethylene resistance is completely out of doubt and it's a really resistant material, it was the better kept plastic. Both in soil, biodegradable and compostable plastic resisted 8 months in use. And this is very important because 8 months is the time that you need for a long cycle crop to finish. So if these plastics can resist for a long crop cycle, then we can say that they are highly promising for being for substituting conventional materials. Regarding mechanical parameters and biodegradability tests, as I said, they were affected by the pandemic, and we hope that at the end of this month we can have at least the mechanical parameters results. Regarding the financial analysis, I will try not to stop too much, but I have to say that the most economical choice, of course, is the conventional alternative. Low density polyethylene is a really cheap material, but the possible losses that cannot be quantified due to environmental damage or the bad image that the sector offers or penalties due to regulations and fulfillment can definitely give an opportunity to alternative materials, even when the cost of the alternative materials is approximately 2.4 times higher than conventional one. And the total overrun has been estimated in 842 euros per hectare and per year. However, we have to add that the addition of compost or biodegraded plastics remains to the soil as soil conditioner can also result in a lower overrun. And also they will reduce definitely expenses as penalties avoidance. And regarding environmental and social analysis, I will go through this very quickly. the conventional alternative environmental impacts is always negative, opposite to the alternatives 1 and 2 in soil, biodegradable and compostable plastics. As I said, the social analysis is also positive for both alternatives. And just for you to have some ideas about the advantages and disadvantages of these alternatives, the first one, the plastic, warranties and eases the inorganic waste management for farmers and warranties traceability control. It contributes to increase a positive image of farmers. So advantages are pretty much higher than disadvantages, which as you can guess, the main disadvantage is the higher overrun compared to low density polyethylene. And regarding the in-soil biodegradable choice, the advantages are very similar, but the main disadvantage is that it requires an inoculate of microorganisms, so it could increase a little bit more the cost. In conclusion, this pilot proved that the use of alternative materials is technically feasible from the point of view of the outputs at the field. And even when the cost of the alternative materials is 2.4 times higher than conventional, illegal abandon prevention and loss due to bad image for consumers are avoided with this kind of plastic, so it can be considered an advantage. And social and environmental impact of the alternatives are both positive. Let me show you some audiovisual material. This is the way that mulching looks. This is a real picture from our pilot. This is the film. You can find it here. And its it's located between rows of tomato crops. This is Reinwaste team that has participated in this pilot. And let me share a video with you so that you have a better idea of what we have done. I will play the sound, but you will hear me explaining what you see. Just a minute. Let me.
Fine.
I will lower down the sound so that you don't hear it so much. Sorry. Let's start again. This is how greenhouses look like on the outside. This is our experimental farm. One of the crops in the experimental farm. And these are one of the varieties of tomato crops that you can find there. This is the installation of the mulching film between rows. This was last October. We did it all over 23 rows. This is low density polyethylene, which is really bright. This is EcoBio, compostable choice, and in-soil biodegradable, biomulch. And this is how the crop looked like after several months. We measured temperature, humidity, and also radiation every day. and radiation every day, and the rest of parameters also on a daily basis. This is a colleague from IFAPA La Mujer. And now you can see the end of the crop and how the plastic is removed and collected. If it was taken to a composting plant, it would just it would only be needed to be all put together and just take it into this composting plant. So it would be quite easier to manage this kind of waste. And now let me tell you about the fourth pilot, energy recovery of difficult to manage waste. Well, as I have said before, the mulching film is considered a difficult to manage waste because of the great amount of sand and vegetable waste that can go with with the plastic. But there are also other types of waste that are classified as difficult to manage. And sometimes there's a legal loophole for this type of waste. There's no EPR, and so the result is always the same. They can be, well, it's not always the same, but it can always be the same. They can be abandoned out in the open. So a possible solution could be the energy recovery of this type of waste that normally does not have an alternative destination. So we are covering here mulching and solarization thin plastics together with thermal blankets. And we have to consider that even when we have classified this type of waste as inorganic in the project, they are mainly organic because the plastic is an organic compound. And so they have a lot of chemical energy that can be recovered through a certain process as pyrolysis or gasification, as we will see. So the specific goals of this pilot were to confirm gasification as a valid alternative for this type of waste and to establish contact with companies that do this energy recovery in the medium range. The company chosen was Coproniger, and we chose it because of the relatively high production of this difficult to manage waste. And well, they have a great production of this type of waste. As I said, I will not stop too much here. But I want you to know that the current management channel for this type of waste is the farmer collects it and takes it to an intermediary waste management company. From this company, it's taken to a final recycling company that produces plastic pellets. That's the normal life of this type of waste. What happens if the intermediate waste management company does not accept this type of waste because they need a lot of conditioning or they find it low profit? They give it back to the farmer and the farmer does not know what to do with this kind of plastic. So we propose this alternative. Farmer takes the waste to a gasification company. In our case, it's Greenie. And this company, after the gasification process, obtains a new resource, which is called syngas, that can be used for producing chemical products or alternative fuels. So it's a good example of circular economy. If we produce an alternative fuel, we can also give it back to the process as electric energy or thermal energy that can go back to the greenhouse. Again, I won't go through this in detail. This pilot started in September last year. It suffered also the consequences of the pandemic, but not that as much as the first one. And we can consider this pilot was finished last June after the advantages and disadvantages of the process were valued by a technician from our co-expert. What I wanted to know from this pilot, from the technical point of view, is that The laboratory analysis that were performed showed that the volatile organic carbon in these samples is so high that gasification stage is not necessary. For those who don't know the process, gasification has an intermediate pyrolysis stage, which is performed at lower temperature. So if we don't need to finish the process with gasification, which requires 1000 centigrade degrees temperatures more or less, it means that we are saving a lot of energy. We can stop in pyrolysis and we achieve a great matter for producing fuel, because the low heating value of the samples is comparative to that of carbon or petrol refining products. So if we consider that previous conditioning is not made by the farmers, it's another great advantage, and the resulting combustion gases will be treated prior to being released to the atmosphere. So what's the only disadvantage of this process? That a normal cooperative or entity such as Copronijar produces a year 160 tons of waste. So this is not enough for process to be feasible. It would be necessary to have at least 15,000 tons per year. So what could be the solution? To establish consortiums among cooperatives so that a gasification plant could be installed in the area. Regarding the financial analysis, if we consider that the plant was already installed, the overrun would be very low, just 22.5 euros per hectare a year. It would be even lower than the cost of intermediate, that current waste management, because this cost is around 35 euros per hectare and per year. And also it would derive in great advantages for the farmers and for the sector. Regarding the environmental returns, they would all be positive for the landscape, for biodiversity, for marine and coastal environments. And also from the social point of view, it would be really positive. Regarding advantages, I have already mentioned them. We prevent negative environmental impacts, positive image, warranty of traceability control, and even possible energetic savings. And the only disadvantages of the main disadvantages that it's not feasible for individual waste production. So a consortium would be necessary. The conclusions are that this option is technically and economically feasible, and the comparative to that of current management waste. And finally, social and environmental impact are both positive. And here you have some materials. This is the solarization plastic. It's used for disinfection of the soil. This plastic is, can you see? You can see it's transparent. After the crop are removed, the soil is covered with this thin plastic, and you can find great temperatures inside the greenhouse. And this effect of the temperature together with humidity and the soil being covered results in a extreme disinfection before a new crop is installed. These are thermal blankets that are another kind of soil covering, and of course mulching. This is the way this type of waste look after crop campaigns, so you will easily understand why they are considered difficult to manage. And now if we have time, Daniela, do we have time to see a short video of the company, or we can leave it for the end if you want?
Fatima, we are running out of the time, but I think I think that these contents are really relevant and really interesting. This is the first time that we have the possibility to share. So take your time, please do take what you need.
Okay, thank you.
Okay, just a minute, I will play it. It's 3 minutes. Can you see it?
Yes. We see your screen. No, you have to change. You have to.
Greenie offers you a technology that's unique in the
Fatima,
world.
Are you hearing?
You are
Fatima?
you
Yes.
share the desktop with the presentation. Now you have to switch to YouTube. So you have to share the tab of the screen launching YouTube.
Okay, so I stop sharing and I start sharing again?
Yeah, exactly.
Yes.
But
Okay.
spotting YouTube.
Okay.
Copy the link in another running.
Just a minute. Sorry.
Yeah, take your time.
Yes, it will be.
Okay.
Okay, Fatima.
Can you see it?
Yes.
Yes, now yes.
Waste into energy and high added value products. Reducing the waste we produce is vital for our planet, and that is why we defend a circular economy that allows it to be valued in a sustainable way. Our gasification process stands out for its versatility, since it gives value to a wide range of organic waste, such as sewage sludge, urban solid waste, industrial waste, plastics, and biomass considered to be waste. Through this process, we obtain a syngas that we can transform into new products with high added value: biofuels, renewable gas, methanol, electrical and thermal energy. All this guarantees excellent profitability whilst taking care of the environment. The Greenie multi-reactor gasification process is a patented design and unique in the world. It is capable of gasifying different types of waste with maximum yield without the need for major pre-treatments. The residue enters our rotary pyrolysis reactor, where volatile substances are extracted by heat in the absence of oxygen. The resulting carbonaceous residue, also called char, enters the gasification reactor, where the carbonate is composed of, is converted to carbon monoxide and hydrogen using air and steam. The volatile substances are then sent to the cracking chamber, where one part is burned and the other is converted, according to temperature, into simple gases such as methane, carbon monoxide and hydrogen. The gaseous currents that are generated in the gasifier and the cracking chamber join together to form the syngas. Finally, the conditioning for its different uses is carried out avoiding pollution emissions. In addition, the ashes obtained during the process are classified as non-hazardous. Our plants are fully automated with a multimedia control and display system that shows us how they work in real time. The professionalism of our team, together with the use of the best materials and components in our plants, mean that we offer high standards of quality and reliability. In short, Greenie opens the door to a more sustainable future, giving value to organic waste to obtain energy, as well as new raw materials with a new life cycle. Greenie, waste to energy.
Okay, let me show you again. This is the end of pilot 4. And now let's finish. With the last pilot. I will try to be short here. The last one is called Comparison of Different Associative Waste Management Levels. This pilot was performed because we wanted to take advantage of a characteristic of this sector, of horticultural greenhouse sector, which is that farmers tend to associate with the purpose of commercializing their products in an easier way. So we thought that important synergies could also arise if inorganic waste management was also a joint effort. So this pilot can be included within the prevention stage in the hierarchy established by the Waste Framework Directive. The application of waste management models, of course, will have an effect on recycling and recovery, but mainly on prevention. And the specific goals of this pilot are to determine the feasibility of the application of different waste management models, to offer common solutions for farmers, and to increase the control and traceability of the waste. The company chosen in this case was Costa de Níjar, which was chosen because currently there is no waste management agreement, and inorganic waste management is performed individually, totally individually, with the exception of Sigfito packaging. Sigfito is an EPR for not all the chemical inputs that are consumed, but only for phytosanitary products that they are collected together in a common point, and they are managed in a common way, but this is the only exception. So we established a different structure of levels, so that when you go down on this graph, you will increase complexity, commitment from the entity that will normally be a cooperative, and also the efficiency of the management. The conventional practice is the individual waste management, as I have already mentioned. And the final stage will be the company becoming a final waste recycler. So we will see these intermediate levels. The first one is individual waste management. As I said, the only exception in the entity, in the cooperative, is the existence of a Sigfito point. The rest of waste are managed on the farm or on their own. Farmers do it on their own. So destination is uncertain. Level 1 would consist of setting agreements with authorized waste carriers, and it would also include the installation of 2 more points for not only for phytosanitary products as Phyto, but also for fertilizer containers. IFAPA point, this would be for fertilizer containers, and also another point for non-returnable packaging containers. And so the documents would all be registered. The rest of the waste would be managed by the associate on its own, but through an authorized carrier that would be common for all the associates in the cooperative. So the traceability is warranted in an easier way, and documents should be interexchanged between the authorized manager and the associates that would return it to the cooperative. The level 2 is very similar, but instead of setting an agreement with an authorized carrier, the agreement would be performed with a waste management company. So there will be less intermediate managers, and the way it works would be very similar. Alternative 3 would be exactly the same as alternative 2, but with an important difference. If you see, the dotted line shows the responsibility of the entity, and here you have everything inside this dotted line, which means that the cooperative is also responsible for the coordination of all the operation, and therefore the level of commitment of the cooperative is higher, and also they can guarantee the traceability of all the waste in a more exhaustive way. In level 4, it's similar to the last one, but in this case, the company, the cooperative does not only temporarily store the waste, but also they condition it, they compact it, and they prepare it, they condition it so that they can take it directly to an authorized manager that will recycle or valorize the waste. And level 4, it's the same as the last one, but in this case, the cooperative, the company becomes a final waste recycler, and they produce inside the cooperative the plastic lentils that are presumably produced from the waste. Regarding the feasibility of the alternatives, first two are highly feasible, and the last two, 4 and 5, are not very feasible from an economical point of view. And alternative 3 is in the middle. They are not feasible because of the great investment that should be made by the cooperatives. But levels 1 and 2 are definitely easy to achieve. So concerning the financial analysis, the cost of implementation of the different management levels are below, but you won't find alternative 5 because it was considered as absolutely not feasible by the expert that performed this analysis. And we suggest that the cooperative, that the way that we could operate would be the cooperative or the society in general could start implementing alternative 1, and if it works, it could start increasing the level of commitment. The environmental returns of all the tested alternatives would be positive compared to the conventional alternative, because among other reasons, they would prevent illegal waste abandon, and they would increase the positive image of the companies in the long run. And social returns would also be very positive because it would involve local job creation and increase quality of life of surrounding populations. Recommendations and well, advantages of the selected alternatives. Well, in general, the waste management would become much easier for farmers if it's made in a common way, and even they would warranty returnable and non-returnable packaging waste, which is quite it's an improvement regarding the normal situation. And if we increase the level of complexity, we will increase also the number of advantages. And also we will improve the waste traceability, and also the management being centralized would warranty all waste management. So in view of the results, the adoption of levels 1 and 2 are the most technically feasible. So we encourage companies to adopt one of these 2 levels. And once they have started with these levels and the installation of I-buy or non-returnable waste points, that would be really profitable for the companies. The adoption of levels 4 and 5 would be a higher stage, not being considered real right now. And in any case, all social and environmental impacts are positive. And finally, although this pilot test was purely theoretical, just for you to have an idea of what happens inside this kind of company, I will show you a video, but it's very short. It's just the way that they process vegetables in this company. It's more related to industrial sector. Tomatoes, so they don't need any plastic label. So natural black bread. Alternative waste packaging. And that's all. Thank you very much.